Now, with our first session today, Dr. Iman Elmahlawy, Professor of Metallurgical and Materials Engineering at Cairo University and an adjunct professor at the Mechanical Engineering Department at the British University in Egypt, and AIST MENA Women in Steel Committee Chair, will talk with us about the future of material engineering, perspectives of sustainability, education, and research. Please, Dr. Iman.
Hello, good morning or good evening, everybody, or good afternoon, actually. First of all, before starting my presentation, I would like to thank you all, especially the organizers and the guests, of course, for accepting to join our students from Suez University and Cairo University, I assume some of them, in this great event, which is, I hope it's going to be a success like the previous events of the Material Advantage. And if you allow me now, I may share my presentation. Okay, so the topic I have selected to talk on today is about the future of materials engineering. The perspectives that I'm going to go through are related to sustainability, education, and research. Actually, what have inspired me to make this presentation or to prepare this work was a trailing chat which was happening on the ASM. I think Dr. Badr has referred to the American Society for Metals, the ASM, which is one of the greatest societies in the field of materials, called ASM. This trailing chat was discussing a very important topic, which I thought it's only discussed in Egypt, but it seems it's discussed worldwide. What is the future of materials engineering? And this question does not raise from the role of material engineering. It rather rises from what's happening now. I mean, the number of students joining this area, the number of students going for this education, the available engineers in societies who can understand and grasp the knowledge needed for materials engineering, the job opportunities, the salaries. Actually, this has driven the discussion. And what amazed me when I went through this discussion, I rarely find time to follow on discussions, but actually this discussion was so interesting. What amazed me was the range of ideas and perspectives which have appeared, from some of them advising not this field, to some of them very enthusiastic about this field. So I went through all the trail and I have made up a summary of what's happening and what is inside these discussions or ideas. So, and then my response was preparing this presentation. So what is the aim of this presentation? The objectives are to analyze the workforce data based on a survey, analyze activities data based on actual work of the mechanical testing lab at Cairo University, follow on the discussion threads of future of materials and metallurgical engineers on ASM, analyze the research activities based on publications, identify challenges to metallurgical and materials engineers, and explore opportunities for the sector and predict the future together with the students, of course. I hope I can receive, and people like Dr. Badr and the other guests, I hope, I'm intending very much to change any of my conclusions if we come up with something fruitful to change what I have foreseen. So why do we study material science and metallurgical engineering? This is because the material science and metallurgical engineers have contributed too much to our current state of civilization. And no one can deny this. No one can deny that all the areas of human civilization has been called after the materials used. We had the Bronze Age, we had the Stone Age, we had the Bronze Age, we had the Iron Age, and now we are on the Advanced Materials Age. So this shows the contribution of materials into the field, let's say the level of civilization that we are enjoying and living on. You all remember at the time when the optical fibers appeared at the beginning, it was thanks to the material scientists, the Challenger that have been able to go through space. I mean, this was thanks to the material scientists and many other applications. The internet, of course, is thanks to the material scientists and many other breakthroughs. I mean, not only, contributed. The material scientists have contributed so much. So that's why people go to study materials science, or which was already known before as metallurgical engineering and now is known as material science and metallurgical engineering. This discussion on the ASM actually have made me stop there. I was interested to find that the topic is discussed on an international level. And I know about the worries of our students, and I know about the little number of students joining this area. And this is good actually because they all find jobs, which is good for them. I mean, so keeping the numbers as low as possible is good to assure job opportunities. Before going deeper into this, my presentation, I would just like to highlight something. Everyone who studies materials or metallurgical engineering is fully aware that in order to survive in this world, to be a successful person, I mean, unless he works for a very specific area, but if he works like for myself, for education or for research, he has to be, and he has to be aware, not only aware, he has to get deeper into other areas, because materials and metals and alloys and materials in general are used in many applications. And this range, one day, personally, one day I would be reading about power engineering, the other day about electrical engineering. Recently, I was reading about dentistry and medical sciences, because the alloys that we develop are used in a lot of applications related to implants and other medical applications. So this just shows you an idea about the hard work that anyone has to do when he joins this area, especially if he decides to work in the field of research and education. The first thing I did was I looked back at the analysis that we have prepared during our preparation for the quality file, which is the accreditation file, of course, for the university. And one of the things we had to do is to look across, where do our graduates go? Where do they work? And I have found that our graduates are distributed among major sectors represented by industry, which is steel, foundry, aluminium, metal forming, industry in general, then petroleum. And in petroleum, of course, they do not work on rigs and drilling and producing petroleum, but they work on all the materials related to the extraction of the oil, the transfer and everything, the pipelines, and here where our engineers would be working. Construction sites would include civil engineers as well as materials engineer working on the steel structures used there for validation, for testing, for assuring that the materials used comply with the standards. Power stations, the same applies, where there is a lot of materials in power stations, and a significant number works in research and education. Actually, the sample that I collected, which is more than 150 students, only one of them reported that he or she doesn't work, and actually it didn't show because it was one of about 165 students, so it doesn't show on this bar chart. Then I started to make a prediction of the number of engineers, material engineers needed annually in those different sectors. Of course, we all suffer from the lack and absence of numbers and statistics which are available on websites which should do this for predicting the future, because actually before asking, or even not before asking, before determining the number of students accepted for each engineering area, there should be a study and a nation consideration of how many engineers do we need, and accordingly the newcomers or the students joining the first year should be in view or accepted in view of these numbers. My very rough expectation based on the number of students from Cairo University, of course, going to these areas, have estimated the numbers that you can see in this table. Actually, I'm sure this is not correct, maybe 50% only correct, and I would invite anyone who can help me on preparing such real or close to near numbers. Actually, it would be very helpful for deciding the number of students in the annual intake of any materials or metallurgical engineering department. The next thing I looked at was the work coming for testing, characterization, failure analysis, study and consultation cases, the work which comes to the mechanical testing laboratory at Cairo University, which is one of the greatest lab doing a lot of services for industry. It's called Mechanical Testing Lab because originally when it started, we were focusing on the mechanical properties of the materials, but now the work has been extended to include other properties which are needed in industry, such as corrosion and other properties. So I looked at the number of customers visiting this lab and the amount of work needed by this lab actually is great amount that requires that the staff working there stays till 6 o'clock every day, 5 days in the week. And this is just a sample of the customers coming. I mean, all these customers are coming for the sake of material validation. We can see tractors, Orascom, engineering industries, melting companies, foundries, machinery parts and spare parts. I mean, the customers are from a very wide background. You can see here, sorry, it's in Arabic, but I mean, this is how the data is reported. So it's just easy for me to take it as it is. Even the new line that the train, the new electric train, العاصمة الإدارية, which is the new capital area, the construction there, power stations, all these are the customers, meaning that all these sectors need materials engineers, because usually the engineers coming with the work or the case to be studied are materials engineers. And here we have more projects like water projects, installation of pipes, of course, petroleum, Zahr, and construction and bridge building and all these things. And this is just images for all these construction sites that have been visited by members of our staff during the work. Then these two pieces of information with the main conclusions that I have collected from the thread of the discussion on the ASM site. For example, I have concluded based on ideas and views presented by the contributors that metallurgical engineering will remain significant for developing countries, as still very large amounts of industrial production of parts are made of metals, such as steel and aluminium. Yet, the expansion of materials engineering in developed countries leads to providing generalists, because many departments there or programs have changed to materials engineering and they do not focus. Of course, you cannot study everything in 3 or 4 years. So if you focus on materials engineering, you have to understand many things about materials, ceramics and polymers, and that's going to be on the expense of being specialized very much in metallurgy. So the countries that, and this is not on my mouth, but this is on the mouth of the contributors, that the expansion of the materials engineering in the developed countries have led to providing generalists to most of the topics, and now they have shortage in specialists in areas such as physical metallurgy and product properties, welding, casting, failure analysis, etc. So I think that education should be inspired by local industrial needs as well as global demands, and what gets attention from industry, financial support, equipment donations, etc., should be considered with priority. And based on that, and not only my opinion, but many contributors from India and other countries just like us, at least one generation more is to be involved in conventional materials, conventional metallurgical engineering areas such as failure analysis, materials forming, welding, etc. In addition to the conventional study or the need for the conventional study areas in metallurgy, we should not forget or ignore our graduates. The future engineers should be involved in other topics such as renewable energy, biomedical devices, energy harvesting and storage materials, materials for batteries, recovery of old materials, superconductors and failure prediction of the superconductors, developing new materials that include quantum physics concepts, thinking about the components for the new computers and the AI that's going to be the future technology, developing new processes and materials, the demands of high technology applications for hybrid and electric vehicles. These are just a number of topics that we see every day in the news, and our graduates should be prepared that they they for surely at least a percentage of them will find job opportunities in such areas. So these also should be included in the education for preparing the new material engineers. Then I looked at Scopus, which reports the trends for research. What are the researchers doing? Dr. Karim Badr has politely referred to university being doing work for industry. Actually, this is maybe this will be 50% or less than the work at university, because the researchers all over the world are more, not more, but equally focusing on something new which is going to happen, which looks like crazy for someone who's actually working on a certain area, but actually that's going to happen one day. And without having people thinking about what's going to happen in 10 or 20 years, we would not have been at the position where we are now. So based on these three sources for finding the information, what should be done? We should operationalize the higher education for innovation, industrialization, inclusion, and sustainable economic development in Africa. And now I have to go to Africa. It's not only Egypt. Egypt has to be a focal point in Africa. So I continue the remaining part of my presentation referring to Africa rather than referring to Egypt. And actually, this would be referring to the region. But Africa needs Egypt more than the other part, because the other part of the MENA region is, or not the, I mean, let's say the MENA region, okay, and the Middle East are developing, but Africa needs Egypt. We should integrate sustainability concepts into higher education to prepare the African youth. And this means that we need science, technology, and innovation, enhancing our natural resources. And of course, the word sustainability or sustainable actions have been mentioned here more than once, because this is the next 50 years at least will be, everything will be thought of in terms of sustainability. So then you will ask, so what is expected from higher education in Africa? Education should spread the word of role and significance of higher education in developing our continent. Education should bring business and academic efforts and minds together to propose and draft action plan for reforming the African higher education to meet the needs of Africa and Africans. Education should bring business and academic efforts and minds together to propose and draft action plan for reforming the higher education to meet the challenges for Africa. Actually, that's going local or regional, thinking of our own problems. And the first one that we have faced during this era was the COVID. Actually, you cannot deny that we work in line with what's happening internationally, but still we have to look at our own problems. And then finally, we should create links and networks for future collaboration. And here you have some pictures. Actually, I like this picture because it shows ages. These very simple things made maybe 2,000 years ago, I mean, have been used by human civilization more than 2,000 or more years ago. Still, it's there. We still use it. Although, or despite the fact that we have gone through all this technology advance, which happens. Now we are developing electric cars, solar energy, wind energy, and others. Now I would like to move about sustainable development. You all hear about sustainable development. What's meant by sustainable development? Actually, I would like, especially the students, because they should know this, that the word sustainability, generally it means doing something that's going to sustain for some time, doing something that cares for being there, doing something that cares for the future generations. I mean, all these ideas are involved in the word sustainable. So very simply, if you want to start a new business, your own business, for example, the first thing you would think of, I would like to have a business that could stay at least for 20 years of my life. I don't want to lose my job after 20 years or before 20 years. So that's the very simple meaning of doing something sustainable. This is the way you think about it for yourself. Think a little bit wider. You will think sustainable means that I don't want to harm others. I want to make use of resources. I want to keep water, energy, resources for everyone else who's living now and who's coming, the babies who are going to come in the future, to find something there left for them. So this is general. But then the United Nations has announced this, their 17 development goals, which are posted on their site. Actually, at least 3 of these goals are very much related to engineering applications, and 2 of them, or 3, are related to materials engineers, very much. The one about energy, you cannot have sustainable energy without sustainable materials. Solar energy would have never been there without the development of the solar cells. I mean, this is just one aspect. I think number 12 and number 11 also are related to materials engineering, which is developing sustainable manufacturing, sustainable products, sustainable patterns of life. All this cannot happen without materials. Which materials am I going to use in the future? Which material should I stop using? Why are people now going to paper and going to ceramics rather than going to plastics or polymers or metals in some cases, for example? But still metals are sustainable because they are recyclable. Recyclability is one important issue for deciding if something is sustainable or not. That's why we say that metals will stay at the top, because they are the best recycling materials, and especially steels, of course. It is the king among recycling metals. But what's new? What's new now? 40 years ago, when I used to go, when we started, or not only, I mean, at my time, they started looking at these issues. Let's think of the 50s. I mean, engineers who studied engineering 70 years ago, they would focus a lot about engineering, equations, relations, a lot of science, engineering science. But now this cannot happen anymore. Now, when you study a specific area of engineering, you have to study many other things next to it. You study material engineering, but you study energy, you study economics, you study environment, you study about emissions, you study about safety, you study about ethics and legalities, social acceptance, everything. So there has to be space for these courses. I mean, at the end of the day, you have a number of credits, a number of hours, but you cannot say that, I mean, this is for our professors, of course, that the students only need to understand about materials and metallurgy. No, they have to understand as well about all other topics. And I have referred to that these ideas or these charts are brought from the site of Dr. Ashby, Professor Ashby, Cambridge University, who is a great man whom I raised the hat to. Maybe he's above 90 now. He's actually a great man who has worked very hard during the last 30 or 40 years for preparing education, databases, information for materials and metallurgical engineers, and he has succeeded in doing that. And they have a very good website on Cambridge University illustrating the findings of Professor Ashby, his societies, and his work. So let's come back to our materials engineers. So when you work for materials engineering, you have to consider, see how many, these are only some points that you have to discuss, think about when you work on the area of materials. Actually, this is wide and global, but still, if you work in any specific area of these areas, you have to think sustainable. Think sustainable every time, even if you work as a production engineer in a foundry or a metal forming or on rebars or charts or wherever. You have to think always sustainable. And this is a range of ideas that may help you in your thinking. Again, we put it together. Materials cannot stand on its own. It has to go in line with energy, environment, society, economics, and legislations. So I have come up at the end of this presentation with some examples for important education topics that may help my colleagues in integrating sustainability actions into their courses and whatever they teach. The first thing I would like to refer to before going to the topics, let's not forget yesterday, back in the 60s. I remember these days. I was a kid, but I remember these days. It was metallurgy, number one. All the programs served or offered in the great universities all around the world were called metallurgical engineering. There were some emerging programs on polymers and ceramics. During 50 years, the metallurgical engineering have expanded or been integrated to be called material science and metallurgical engineering. And actually many, including the school where I learned metallurgy. I took my PhD at Leeds University, and it was called School of Metallurgy or Metallurgical Engineering Department, and now it's called the Material Science and Energy Department. So what is the difference? Material science would include, in addition to topics about metals and metallurgy, mechanics, structures, design, and economics. What's going to happen tomorrow? Tomorrow, the programs will be called Materials Systems and Design. This is an expectation. It's not me who made it. It's Professor Ashby. He expects that the future programs will be material systems and design, and this will integrate, in addition to previous topics, sustainability, environmental, economic, and social impacts. So how and where should materials fit into this new expectation for the future? Actually, this slide just shows what I have just explained in words now. So, what should be the objectives of future materials engineering education? The mission statements called like mission statement. The questions you ask yourself, your 5 best friends, wherever you go, go with them. And the 5 best friends are 5 questions. How, why, what, where? How can I do this? What should I do? Why should I do it? I mean, these are called the 5 best friends. So what should the objectives, first of all, the objectives, before doing something, you have to determine the objectives of education for the future. Related, of course, I'm talking about related to materials engineering. It should provide a framework within which a student can form critical, independent assessment of sustainable development. And this is different. In the past, we used to focus about information. We used to study a lot of information. Information was very important because the whole area that I lived in with my generation was the whole globe was looking for information. But now is information is available just at the tip of your finger. You just put the right keywords and you find all the information you need. But you need to read this information. You cannot read it without understanding. You cannot read Chinese or Indian if you do not know the language. So you should know the main terms. You should understand the concepts. Education should provide these concepts. Your work from now on is not going to be putting a lot of information in your mind. Your work is going to be further beyond that. It's going to be making critical, independent assessments of material selection, choice, considering sustainable development. Your work is going to be related to fact finding. You have to find the fact. Now, you have to find the fact not in your mind, but in all sources available around you. You have to find the fact. You have to be capable of finding and allocating and seeing these facts. You have to understand the role of materials in sustainable development. Don't think that sustainability is for other people. No, sustainability is 50% for materials. You are the one who is going to make the steel. And you're the one who's going to consume energy. You are the one who's going to provide a product that's either sustainable or is going to fail after 1 year. You are the one who's going to choose the material for the future. Is it going to be this or that? So making this decision is not easy. You should appreciate the significance of considering sustainability in materials, not only material selection, in the whole design process. You may suggest a design in a part, mechanical engineering design, because this design does not fit your material selection. So design should be looked at. Manufacturing, the whole process of manufacturing, including the number of process stages, the energy consumed. Why do I do this step? Is it necessary? Should it be like this, or can it be simpler and less energy consuming? Consumption, the end of life of the part, its recyclability. Am I making a product? I mean, when people talk about adding, for example, reinforcement and adding nanoparticles, we have to question every time, okay, what about my product? Is it recyclable or not? Imagine that every single action that you do, you should think about all these aspects at once. You are going to, it's a very difficult decision. I mean, you are going to be just thinking crazily. Am I going to do this? Is it worth it? Should I do it? Am I right to do it or not? And then the ability to propose and analyze ideas for sustainability. You have to be ideas presenter. You have to be a novelist, not only an I missed the English word for تقليد. You're not only a follower, okay? So imitation. Okay, thank you. Yeah, thank you, thank you, doctor. Yeah. So so what topics should be included? I think that those topics should be included in the courses, and not only me, of course. I mean, these ideas are presented based on a lot of reading, going through conferences, listening to presentations. So we should learn about conservation of minerals, conservation of energy, reducing global warming, reducing solid waste. And I'm glad that Dr. Badr has started his presentation with all these new topics and ideas. This just shows you how industry is thinking, and that's how education should think. We should, the students should be taught about the challenges. How do we know about the problems? Current use of steel and aluminium and why are they used? Steel and aluminium should be well studied. They are there for the future. Novel manufacturing processes routes should be introduced, out of the box ones. Do not think that this is the only way. You may think of others. Using less metal by design, redesign for recycling, reducing yield losses in industry. Every single gram that you save as a lost material due to being defective in the industry is an addition. diverting recycling scrap to other uses before melting, reusing the metal components, producing longer life products with delayed replacement, options for change in major products made by steel and aluminum, and compulsory. Everyone should learn about what can we do to use less, recycle more, and use plastic for more. The actions of individuals. How should I, as an individual, behave? Energy-related carbon dioxide emissions. These are not material topics. These are personal topics that should be taught within a course, any course. Dr. Badr has referred to global warming and carbon dioxide emissions. Actually, this is true. It's not imagination. A lot of statistics are available on the website showing the increase in the dioxide emissions and the increase in the temperature of the globe. What are the adaptation strategies? Actually, now the whole world, we are going to have COP27 in Egypt very soon, in less than a month. World leaders are going to come and gather and collect ideas and talk about what legislations have they made in their countries in order to adapt to climatic change. We cannot reverse it, we cannot combat it, but we have to adapt to it. This adaptation would be covered in all major aspects of life: water, agriculture, infrastructure, human health. There should be adaptation, and materials would come everywhere here. Everywhere you use material in conveying water to people, to cities, to rural areas. You use material for making the solar pumps, for making the pipes, for making the agricultural engineering equipment. You use material. Infrastructures, you have just seen that steel structures or new structures which are going to be proposed, even if not made of steels, are made of materials. Human health, a lot of research is ongoing now. When you attend an material engineering conference, half the session would be focused on biomedical materials. Transport, of course, we need not talk about storage, energy storage and batteries. This is all materials job. Energy and renewable energy and energy saving, at least 30% of this is covered by materials engineers. Ecosystems and how to affect the ecosystem and keep it sustainable and keep the creatures on this earth without harnessing or without harassing them. Cost and economy should be considered. Do not ever feel sorry or upset because your supervisor in work or because your university is thinking about everything money-wise. Everything should be considered, not money for the sake of money, it's for the sake of economy. When I do something, I have to do it at the least economic losses, with the least cost. So everything should be fitting within the economy. And that's why economy is a very important topic to be taught for engineers. We used to tell our students that engineers are very stingy scientists who do not want to spend money. Here I've just put a record of the important events from the international point of view for the climatic changes. It all started in 1992 in Rio de Janeiro with the Framework Convention on Climate Change, and then came Berlin Convention, and then Kyoto Convention 1997, and then Bonn 2001. The Conference of the Parties, number 6, have taken another step, where the COP, meaning the Conference of the Parties, now is the major doer and actor in the field of climatic change. And the main COPs that have happened were 6 in 2001, 15 2009, 11 in Durban, 15 in Paris, and actually we can add 2021, which was in Glasgow, because this is a mark where I have to add, actually, this is a mark where the ideas of meeting the global challenges have changed. Instead of combating and fighting, but now it's adapting. We have to do adaptation. We have to use what we have and consider what's there for the future. So the conclusions of this presentation are, or actually show, the role of climatic changes and sustainability, finding ways to recycle and or dispose materials, Revision of standard specifications. Actually, this is a very important topic. I expect that standard specifications that we use should be revised because many of them are based on materials made from raw material. Now materials are going to be made from recycled materials, and that's going to open the chances for some changes in these specifications. The role of industry in shaping educational programs, that's going to be very important in the future. Actually, we will not be overdoing it if we say that each university have to partner with an industry in its local area and design all its education serving this major industry or group of industries. Job security is very, very important. I call on everyone attending this presentation. We should not leave the future for digital age only to control us, robots and arms and manipulators. We should keep people happy. People should be working. We should always find a job for people. We cannot have a future without finding a job for people. People are not on this world to live eating and drinking and that's it. They have to work. Work is a great enjoyment and satisfaction in life. So the right of the citizens to have a decent job. Jobs should not be for robots. Right of youth and next generations to receive appropriate education. Right of people to enjoy a natural as much as possible life. The human being should be the focus of the sustainability goals. And this is the list of references that I've used. Thank you all and sorry if I have kept you for a long time. Thank you very much.